very much for that wonderful introduction. Hi, I'm Jake Levine, and welcome to Lazy Engineering. This was working a couple minutes ago. Hold on. I'll just do this. As described, all the same information. But I'll also add that I am a lazy engineer. I'm willing to admit it. But what does that mean? Well, it means I still have some work to do on this presentation. But in all seriousness, what does it actually mean to be lazy? So, lazy, unwilling to work or use energy. It's a feeling I'm sure all of you have felt before, some way or another. You just really don't want to do something. It sounds hard. There's usually a reason why you don't want to do it. If it was easy, maybe you wouldn't feel that lazy about it. But you'd rather be doing something else. And as a side note, this word actually comes from German. Das ist sehr interessant. Excuse my German, it's really terrible, but it comes from the root lazisch, yeah. Just thought that was interesting. So anyway, the preconception of laziness is that it's a bad thing. If you hear someone say, oh, that engineer is lazy, it sounds bad. It sounds like an insult. But it doesn't have to be. Laziness, I think, is an important skill. Say what you want about this man, but he has found a very efficient way to eat his Cheetos while playing video games. And in this talk, I'm going to prove to you that laziness can be an important part of being a good engineer. So how can we apply this to engineering? If laziness is bad, then the opposite of laziness would have to be good, right? If I was building my dream team of engineers, I would want a team full of non-lazy engineers who, my own code Avengers. I'm in a movie theater, so this feels really appropriate right now. I'd want a team full of, I don't know, do we call them 10x engineers these days? I'm not sure. But what do they look like? Who are these engineers? They're solving every problem that they're asked to solve, every requirement. They're finding a solution, working hard until every problem is solved, no matter what. They're building complex systems that account for every possibility, every use case, every edge case. They're solving it all. And they're also working on 12 of these things at once, obviously. And actively memorizing all the information that they need so that they can answer any question about any project or any technology or any topic on the fly. And it sounds great, but it also sounds pretty exhausting, right? Being a superhero also makes you pretty sleepy. And also, maybe solving and implementing every requirement that you're asked to solve doesn't work out in the sense that maybe your requirements change or your project changes and you actually wasted a lot of work and everything you built comes crumbling down and why did you build all of that? Those systems that account for every possibility. Maybe you build a robot like this cartoon that was built only to serve butter, but actually has feelings and thoughts and ends up with a lot of existential angst, which is maybe a convoluted example, but the similar idea. If you put building too much, you build a lot of things that never get used. Working on 12 different things at once, and maybe splitting your time on 12 things actually means that each one of them gets done slower or worse. Remembering every detail of every project? Maybe you try to keep so many details in your brain that you forget some or misremember some of them. So we're all engineers because we like solving complex problems. We like to battle technology dragons. But solving complex problems also takes a lot of energy. And I want to make sure that I'm spending my energy in the right way. And I think efficiency is key here. You don't want to lose all of your e-coins or whatever because you wasted all your spells. And as a side note, there's also a concept already in programming of lazy evaluation, where we are delaying, possibly indefinitely, the computation of values until they're required, which saves wasteful work. The concept is there already. So how do I tap into my inner laziness to be more efficient in other ways? So I'm going to propose 4 laziness principles that we can follow. So principle 1, question requirements. Cheeto Man, he's back. He's really putting to test requirements that you may have assumed about how to eat Cheetos, like needs a table or needs a napkin or something. But in contrast, our non-lazy engineers that we were talking about before, they see a list of requirements, and they come up with a solution that fits every single one. And that's not a bad approach. I think your heart's in the right place if you're going that way, but there are a lot of things that could go wrong. So this is one of my favorite comics. So, oh my God, it's huge. So the product owner is talking with their engineer and wants to build an app that does a couple of things. They want it to given a photo, check if that photo is taken in a park, which the engineer says, easy, got the metadata right here, we can do that lookup. And they also want to know if the photo is of a bird. And I think maybe technology has evolved a bit since this comic came out. Maybe that actually is easy now, I don't know. But at the time, something like that would have taken like 5 years. And the engineer tells them. So like, if you're just going based purely on what the product owner is asking, and you try to build these things, it's probably going to take a long time. And the engineer, though, has knowledge in their head that the product owner doesn't have, and they can have a conversation about that. But I know many engineers who would just say yes to everything that's asked of them, which is an admirable trait. But it's not doing people favors if you agree to do impossible things in an impossible time frame. So you'll end up either under-delivering, which will disappoint the people around you because you promised to do something and then ended up doing less. Or you'll be working yourself so hard that you're basically working constantly, evenings, weekends, et cetera, which is bad for you, unfair to you, and I hope none of you are doing this on a regular basis. I don't think it's maintainable. So when you see super complex requirements, maybe it's okay to give in to your feeling of laziness. There could often be an equally viable requirement to use instead, that it is enormously less amounts of work. Because often the people who are writing requirements don't have all the information about the systems that you're working in. They don't understand how it translates into work. And in many cases, they would actually prefer something a bit different if they knew it would get done a lot faster. So as an engineer, I would encourage you to try to bridge the gap between yourself, your team, and product design and business people who you're working with. Try to understand their goals, and then propose solutions that can accomplish those goals directly. And if you do, everyone will be feeling pretty good. So here's an example. I once worked on this project where we had a customer with large lists of contacts, and they wanted to use MailChimp to send emails to those lists of contacts. So we had this list of requirements that the product manager came up with. The user needs to authorize with MailChimp. They need to select a MailChimp list to synchronize with once per day. We need to resynchronize the list, and they also need to synchronize right when they authorize. If errors occur, we need to handle them. The user can disconnect the integration whenever they want. Here's the architecture for it. It's not actually important, don't read too much into this, but I just really want to point attention to how many different boxes and pieces there are. Even for something which I think, when I described the previous project, it's not impossible, it's not groundbreaking, but it's still work, and it's still a lot of steps and a lot of things you have to do and pieces you have to build and things you have to fit together. You have to monitor all of this, you have to validate all of this, and you have to build all these things around it to make sure that the feature works. Given a project like this, what if we just got rid of all the requirements? Wouldn't that be nice? But actually, when I talked with the product people who were proposing something like this, ultimately it turned out that there was actually just one unspoken requirement. The rest were just implementation details, and that was the user can easily get their contacts into MailChimp, and that's pretty much it. I mean, the rest of it is just one way to do it, but it turns out that there are other ways to do that too. So we built this fun modal, and modals are easier to build than giant architecture things. So some background on this though is that we already had a export to CSV functionality for all of your contacts, and MailChimp already had a import from CSV option available on their platform. So all we had to do was tell them how to use that. This isn't as glamorous, this isn't as exciting of a project. it doesn't accomplish the same thing, but it's also much more efficient. We only had to make a couple of changes. We had to build this pop-up, and we had to slightly change our CSV export format so that it actually just seamlessly worked when you tried to import it on the MailChimp side. But after taking the time to understand what the users were actually looking for, it turned out we could build something that accomplished that without spending multiple weeks in sprints trying to build this more complicated piece of infrastructure. It's definitely less elegant, like I'm not gonna lie about that, but at the very least it let us put this feature out there in the world earlier and get feedback from people about how they were actually using their integration with MailChimp and trying to get data about whether it was actually important to keep investing in this area in the future. Building this didn't prevent us from building the first solution. In fact, I think we actually did eventually anyway because it turned out that people were really using this a lot. But if it turned out that people weren't, then we would have saved a lot of work. And also a note about this, unless you're like the only person on your project, don't unilaterally change requirements without talking to the rest of the people on your team. I just want to make sure that that's clear. This should be a group decision. You don't want to surprise your product owner with a completely different feature. Okay, let's move on to principle 2. Keep it simple. Our Cheeto man, again, he's really living in the moment. He's found a basic way to accomplish all of his needs: hunger, rest, entertainment, all with one simple solution. But what about again, I'll bring it back to the non-lazy engineer that we keep talking about. She's always a step ahead, trying to predict the future. They're anticipating many possible use cases and directions that a project could go, and preemptively building their software to fit those needs, and going out of their way to write their code in as sustainable of a way as possible. And again, as with the last principle, their heart is in the right place. I mean, it's the future, right? Like, who wouldn't want to live there? Here's another one of my favorite comics. This person over here, they just want some salt so they can enjoy their meal. There's a lot of food-related things I'm just realizing right now. So they're asking their friend, or engineer friend, I guess, to pass them the salt, and they're instead told that the engineer is developing a system to pass arbitrary condiments, and it'll take 20 minutes. It's already, yeah, so I mean, that could be a really cool system for passing arbitrary condiments. Maybe it already exists, I don't know. But meanwhile, this person's sitting here for 20 minutes without salt, so they can't enjoy their meal, and that's terrible. So I think this shows that short-term efficiency is really important too. You want to be able to deliver things quickly and often, and not always be focusing on the far future. As an engineer, there's always something else to do. There's always another way to make your class more generic, another way to organize all your source directories, more edge cases to solve. And you usually don't know where the future will take you. And when you think you know, it'll probably still change. Ultimately, none of us can truly predict the future. We'll always be wrong some or most of the time. So what is all of this extra complexity buying you? Not too much, I think, but what are you spending? Time. It's not only that you're spending extra time yourself, your code also becomes much harder to reason about. You're adding more complexity. It becomes harder to make changes. It's harder to understand what it's doing. And it takes longer for other people also to jump in and understand what your code is doing too. So when you were spending all of this extra time building new features, adding things on, are you making sure you're accounting for all the extra work you have to do? Are you just fixing that, like adding a new feature, or are you actually also like adding extra end-to-end testing to cover that feature? Are you adding extra documentation to cover this new logic that you're adding to prepare for the future? Like, you might be doing all these things, but it's just something to keep in mind, is that it's never just as easy as making some quick changes. You always have to follow up on the stuff you're doing, and the amount of time that you add kind of tends to snowball. So I would say instead, start small and stay small as long as you can. Build only what you need to. Be efficient. What's the simplest, quickest thing you can produce that solves your problem? Eventually, if you did want to end up with a car, I mean, a lot of you have probably seen something like this before. You could jump in and try to build a car right away, but that's going to take you a really long time. And if you just start building a car, the pieces in between might be useless unless you start building something simple that still works for getting you from point A to point B, like a skateboard. But you might say also, like, I mean, the future's important too, right? Like, we do have to consider it in some ways, at least. And people have been trying to plan for the future for forever. People coming up with what the future might look like, usually being wrong, by the way. And it might sound like this concept is ignoring it a bit, but I would say lazy engineers aren't ignoring the future. We're actually trying to optimize for the future. Lazy engineers are lazy and don't like having to do the same work twice. If you're building simple components, it'll be a lot easier to reuse them or build on top of them later on. For example, Disney animators are also pretty lazy. They saved time and money using the same basic animation frames in different movies, both of which were successful movies. So like they must have kept the building blocks that they had before for this animation and just reused it again later on. And I guess someone noticed eventually, but still both movies did well, so it worked out. And when I say to build something small and simple, what I actually really mean is to build something that is as unopinionated as possible. Try to make as few decisions as possible, or at least delay them as long as you can. Don't decide on anything that you don't have to. As a quick example, if you're building a prototype for something, you might need a database eventually. But if you don't need it for your specific prototype that you're building, don't choose one yet. I mean, you have a couple of pretty standard options. They have their pros and cons. But I would also argue that a third option of no database is very high performant, has infinite scalability, doesn't have any data storage, but maybe you don't actually need that for your MVP right away. I mean, granted, you will need a database eventually, but if you, at the very early stage of your project, make this decision before you truly have to, you might be limiting yourself in terms of the functionality that you can add later on. Spend less time now, defer your decisions until you actually need to make them. It's often really tempting to build generic solutions for things, but I would also say to defer the decision to do that too. Take, for example, data collection. Let's say, for example, that you're asked to implement tracking around the number of clicks on a particular button on a particular page. You start to implement this and suddenly realize, well, it would be pretty straightforward also to just collect data about every click on every button on every page. Why not? We'll need that data eventually for something. So, being the non-lazy overachiever that you are, you attempt to solve all of your company's future tracking problems by implementing tracking globally on everything instead. But suddenly, the system you were using to handle tracking data is now struggling to handle all of the influx of new data that it's receiving. And it's costing your company tons of money to pay for the huge blow up in data storage costs. And your company goes bankrupt, and it's all your fault. Okay, probably wouldn't happen quite that way, I hope. But do you want to risk it? I would say it's better to just be lazy. Okay, back to Cheeto Guy. Principle number 3, do fewer things at once. So Cheeto Guy, granted, is doing 2 things at once. He's eating his Cheetos and he's playing his video game. But imagine if he was less lazy. He would probably have his Cheeto bowl elsewhere, and maybe it's on the floor, and he has to put down his controller to reach for the Cheetos. Then he has to feel around for it, grab one, and pick it up. And meanwhile, I don't even know what's happening in his game anymore. Hopefully he paused it, but now he has to go back and unpause it and remember what he was doing. It's a nightmare. It's also probably quite rare now to see Homer Simpson about to be used as an example for being less lazy, but here we go. Our non-lazy engineer is always working on tons of different things. Right? They're taking on tons of different projects all at once. And multitasking, I think, is a great skill to have, but it doesn't necessarily mean that you should always use it. Homer is on the right track here. I mean, he's still being somewhat lazy, I would say, but look at all that arm movement. He's going to tire out really quickly. This is how a lazy engineer reacts when you ask them to take on more tasks in parallel. Lazy engineers dislike multitasking. But why is multitasking bad? Unlike SpongeBob up here, we do not have this many arms in real life. Rather than doing all of these things at once, in reality, we're actually just switching back and forth between these activities. I mean, like, it might feel like you're doing everything at once, but ultimately, like, you're really only just focusing at one at a time, maybe switching tabs or switching consoles, I don't know. This involves a lot of context switching overall. But why is that bad? What's wrong with context switching? Every time we switch, we suddenly have to remember all of the context that's related to our new activity, where we left off, what the remaining open items are, etc. So we find ourselves asking questions like, what year is it? Where am I? What's going on? This is me every time I switch between tasks or repos or meetings or whatever. I need to take some time to re-remember all of the basic important details. This takes time, it takes energy, and it's pretty inefficient. And there are ways to manage this and make it easier. I'm gonna get back to that a bit later. But also, just doing fewer things at once is not about managing your workload. Not only about, at least. We can also extend this principle to code and the development process as well. Maybe, like me, you have at some point found yourself working on a task and thought to yourself, well, I'm already in a branch. I may as well just fix this other thing as well here and wrap it all together and get them both done at the same time. And, oh, that bug would be an easy fix. While I'm here, I'm gonna fix it. And before you know it, you end up with something like, oh, my goodness. There we go. Like that. Raise your hand if you're up for code reviewing that pull request. Anyone? I see a handful, not many. Maybe you'll have to bribe your coworkers in order to get it reviewed with like beer or snacks or trips to the Bahamas or I don't know, just so they could take a look. I mean, that's a lot. That's a big investment. Changes like this are much harder to review or validate correctness on. And the odds of something going wrong with one of the 353 plus changes are super high. It's really hard for anyone, engineer, anybody, to keep awareness of everything that's happening in this branch all at the same time. And the lazy engineer would never make a PR like that. Also, they would definitely never review a PR like that. So keeping your code changes small and organized lets people review them with more confidence. It also lets you deploy these changes with more confidence. If something goes wrong, you can isolate it to your small change. Keep each change isolated this way, work on one at a time. You will get people to review your code, no problem. You don't have to bribe them with anything. Also, when one of these changes inevitably breaks something, because come on, we're engineers, it happens sometimes, you can more easily identify which changes caused those problems and roll just that one back and not the entire mega branch and spend more time on just fixing that piece. So, principle 4, we're back to Cheetah Man one last time. This is the last principle. He knows where his controllers are. He knows where his Cheetos are. He has everything he needs. But if the Cheetos were on the floor, he'd have to feel around for them and figure out where they are, and his attention is taken away from the video game. Bad news. He doesn't need to remember where they are this way. They're just literally right in front of him. The non-lazy engineer knows everything. They have the answer to every question contained in their head. The exact wording of every project requirement, every project's GitHub repo slug, everything. Whether the method to get the number of items in an array is length or size in every single coding language, etc. This is something I have to Google every single time. Like, it sounds really basic, but like I always am pretty sure I'm about to get this wrong. And maybe your IDE will tell you or something like that, but it ends up being different. And ultimately, like, it doesn't matter if you remember this because you have the internet. You can just Google it. I mean, if you have a photographic memory and can remember every little detail, cool, but I don't. So like, why bother trying to remember anything? I'm always 2 seconds away from that information. Brains are unreliable, and we have to work with this fact and not against it. So let's borrow a concept from functional programming to where we want to do things like avoid shared global state, where we want to have components that avoid statefulness, and they're focusing on transforming inputs into outputs without outside dependencies. And they're not sharing resources and things like this. We can apply this to our brains too. If we only, when we're working on something, we want to just focus on that one thing. We don't want to be distracted, but ultimately we are. There's lots of thoughts and things going on in our head at all times about other projects, about our people, relationships, meetings, what you're going to eat for dinner that night, etc. We don't want to forget about these things, but we also don't want them to bother us at the time. So how do we focus on what we need to focus on, remembering the details we need right now, but also not losing the details that we don't need right now, or at least losing them permanently? It seems simple, but computers can remember things so that we, humans, don't have to. When you need to remember something, when you need to keep state, you can just write it down. Documentation is inherently lazy. Who wants to keep track of all of the information in your brain? That sounds like a lot of work. Once documentation is written, you don't have to remember it anymore. And, as a side benefit, other people don't have to remember it anymore either, because it's all there in your documentation, in your notes. So, official documentation is good, but you don't always have to start there. Take notes, however, is the most useful for you in the moment, just to get it out of your brain and somewhere else. Google Doc, handwritten note, whatever. Write the things down that you need to when you need to switch away from something. If you're about to switch to something else, just take 10 seconds and just write down every single thing that is currently in your brain about the current state of what you're thinking about. And then once it's on the paper, you can forget about it. Go move on to something else. And when you come back, just read it again. And it's not exactly the same as if you hadn't switched focuses, but I do this all the time, and it saves me 90% of the time it would have taken to remember everything just by taking a little bit of time for myself right before switching away. So this helps obviously a lot with context switching, which is something that normally drains a lot of your time. And I know I said it's something to try to avoid earlier on, but you can never truly avoid context switching. It's going to happen. There are things outside of your control that take time. You might have to go to a meeting. You might have to wait for a deployment, wait for a code review, or take a lunch break. Things happen. You're not going to be working 24/7. But just to point out, context switching is a lot easier when less context is needed. So try to reduce those contexts that you need to be super on top of, so that you can work on a few simple things at once. Something else that's lazy is infrastructure as code. I highly encourage any lazy or lazy prospective engineers out there to look into this. You are basically writing down your infrastructure so you don't have to remember it later. There's other benefits too, obviously, but you can see how it all fits together just by looking at this file. And if you're using a deployment framework to manage deployments, you also don't have to remember how to deploy your code either. And it saves a lot of room in your brain to think about other things if all this stuff is just written down and handled for you. Okay, so now we're at the end of my presentation. And to wrap up, I did not write a conclusion. Instead, I'm going to question the idea of a conclusion in the first place and try to provide an easier alternative. I'm going to provide you with the simplest possible thing instead, which is instead of talking about every idea that I already talked about all at once, I'm going to leave you with the knowledge that all of this information is written down on my slides, on a video, and you can just watch it again and look it up on the internet whenever you want. So, oops, maybe I did write a conclusion after all, but I did it the lazy way. And anyway, I hope I have convinced some of you that there is some merit to laziness. I'm a proud lazy developer, and you can be one too. And you can find my personal page there, and I'm also up for some questions if anyone has any.